This video is about solving problems involving a ramp or inclined plane. So this is a two-dimensional forces problem because we have an angle. So some of the forces will be in 2 dimensions here and some of them will be just one-dimensional. So an object of 9.3 kilograms rests on an inclined plane. The angle of the ramp is 23 degrees. Find the magnitude of the friction force. So notice the object is at rest. It's resting on the inclined plane. So we know some of the forces are equal and opposite because there's no acceleration. The object is at rest. So what we do is start with a free body diagram. So we can draw something like this for the ramp. And the angle is 23 degrees. So there's our angle of 23 degrees from the horizontal. So we measure up from the horizontal, 23 degrees angle of the ramp. And the object is resting on the ramp. So we can draw a free body diagram for the object on the ramp. And then think about the forces that are acting on this object while it's at rest. So there's always the weight, Fg, which is always straight down. So no matter what the orientation of the object, the weight is always directly down. So there's our weight. We also have a normal force because this object is at rest on a surface. So anytime there's a surface, we have a normal force. And if you remember from the notes, the normal force is always perpendicular or 90 degrees to the surface. So our normal force is here. So we have the weight, we have the normal force. We also have friction because we're asked to find the magnitude of the friction force. So we have to decide now which way do we draw the friction. So if you think about the situation, if the object is at rest on the ramp, there's no, it's not going to roll down the ramp or move up the ramp. So it's balanced by some opposing force. So if you think about if there was no friction here, the object would roll down the ramp or slide down the ramp. So that means that friction is opposing the motion or potential motion of this object. So we can draw the friction directed up the ramp. So opposite the direction that the object would move if there was no friction. So we have an angle here. This angle given in the question, 23 degrees, is also going to be the angle inside of here. So our weight is going to be a two-dimensional. It's going to have a y component and an x component. So the y component is straight down like this. You can notice it's parallel to the normal force. This would be Fgy, the y component of the weight. And remember, the only reason the weight is two-dimensional is because there's an angle here. So we can make our right triangle like we always do. So we have the y component, Fgy, and then we have the x component down here. Just to maybe clean this up a bit, I'll just move the Fg over to the other side here. So the actual weight vector is Fg, straight down. And then we have an x and a y component for the weight. So we need to find the magnitude of the friction force here. Here's our friction force. It's going up the ramp. So if this object is at rest, that means, if you remember, that means the net force is 0. F net equals 0 here because the object is at rest. So in the x direction, the net force is 0 moving along the ramp. And in the y direction as well, the net force is 0. Because the object is at rest. Anytime the object is at rest, the net force is equal to 0. So how are we going to find the friction force here? If we do the net force in the x direction, we add up all the forces that are in the x direction. So this is the surface of the ramp is our x, kind of our x-axis, and then the normal force and the y component of the weight are on the y-axis. So looking along the x-axis, we have the friction force, and then down here we also have the x component of the weight. And so when we write the net force, it's the friction force plus the x component of the weight. And these are going to be equal and opposite. The net force is 0. We know this because the object is at rest. So we can write 0 for the net force equals the friction force plus the y component of the weight. And if you remember from 2D vectors, if you're finding the x component of a force, you just take the force and multiply by cosine theta normally. In this case, if you look at this triangle, if you remember I said ramps are a little different. If you look at the triangle, the x component is opposite the angle. So that would be sine. So only when you're doing ramps, the x component is f sine of the angle. So in other words, that's going to be fg times sine of the angle, which is 23 degrees. So very important. Usually finding the x component is always cosine, the y component is sine. If we're going to draw our triangle like this, and if we want to use the same angle that's given in the question, we have to use sine for finding the x component. So we're looking for the friction force, which is right here in our equation, and so we can just rearrange this. So the friction force, we're going to subtract this piece, is equal to minus fg times sine 23. And if you remember, fg, weight, is m times g, 9.81 meters per second squared. So minus fg would be minus mg times sine 23. So our mass is 9.3 kilograms. G is going to be negative 9.81 meters per second squared. So I encourage you to try this calculation on your own. I'll do it right now. So 9.3 kilograms times 9.81. So this is going to be positive because we have a negative number here in front of the mass, and g is also negative. And then we're going to multiply by sine of 23. And I get 35.6 for some other digits, so maybe 35.6 newtons for the friction force. That would be positive. We got a positive answer, which tells us that the direction is up the ramp. Down the ramp would be negative. If you think about significant digits, last thing I wanted to say, you look at the number of digits in the question, right? 23, so there's 2 digits there. We have 3 digits here. So the least number is 2. So we're going to answer to 2 digits, which would be, you could round this to 36 newtons. 35.6 rounded up to 36 newtons. So the friction force is 36 newtons. And that would be equal and opposite to the x component of the weight. So the x component of the weight would be negative 36 newtons. So these two forces, the x component of the weight and the friction force on a ramp, if the object is at rest, these forces are going to be equal and opposite. So if you know if you can find the x component of the weight, then you know the friction force.